In this video, we're going to be looking at upper and lower bounds. So, if a piece of wood is 600 millimeters to the nearest 10 millimeters, it could actually be from 595 to 605 millimeters. So, using this piece of information, we can apply and interpret limits of accuracy. So to understand this, let's have a look at an example. If Jack is 1.8 meters tall and Ella is 1.63 meters tall, both rounded to the nearest centimeter, what is the smallest possible difference in their heights? If Jack is the tallest, and he is 1.8, and Ella is a bit smaller at 1.63, to find the smallest difference, we have to take the lower bound of Jack and the upper bound of Ella. Jack's lower bound is 1.75 meters, and Ella's upper bound is 1.635 meters. Now to find the smallest difference, all you have to do is subtract. So 1.75 subtract 1.635. Cross out the 5, make it a 4. 10 minus 5 is 5. 4 minus 3 is 1. 7 minus 6 is 1. And 1 minus 1 is 0. 0.115, which is equivalent to 11.5 centimeters. And that is the smallest difference. Let's have a look at one more example. If a piece of A4 paper is 21.1 centimeters by 29.7 centimeters, measured to the nearest 0.1 centimeters, what are the lower and upper bound of its area in square centimeters correct to one decimal place? So what we're going to have to do, let's take each length individually, 21.1 centimeters. Now the upper bound and lower bound. If we know that it's measured to the nearest 0.1 centimeters, we know we have to plus minus 0.05. So the upper bound for 21.1 will be 21.15, and the lower bound will be 21.05. 29.7 centimeters, the upper bound will be 29.75, and the lower bound will be 29.65. Now, to find the maximum possible area, we have to multiply the two upper bounds, and to find the minimum possible area, we have to multiply the two lower bounds. So, if I take the upper bounds and the lower bounds, and I multiply them together, so maximum area will be equal to 21.15 multiplied by 29.75, which equal to 629.2 centimeters squared to one decimal place. And the minimum area will be the multiplication of the two lower bounds, which is 21.05 multiplied by 29.65, which is equal to 624.1 centimeters squared to one decimal place. And that is how we use upper and lower bounds to interpret limits of accuracy. Thanks for watching.